is that rarely do I ever give someone an explanation of why it's true, and then they say, I'm still lost. You lost me, right? Typically what happens is, hey, look, the two angles are vertical. You're like, oh, man, I see it now. And that's just kind of how it rolls the whole year. All right, we are going to just collect the homework today, and then we're going to move right on. So somebody grab the basket over there, has geometry, and collect homework and pass out. We took the quiz yesterday, right? Or was that Wednesday? It was Wednesday. Okay, so it's already graded. It's in the grade book. As a group, we did okay. It's okay. I don't see anything that's causing me great concern at this point. I'm seeing what I typically see in a geometry class. All right, homework's on the board for tonight and over the weekend. I think that last class was the easy class. Today's the hard class. You will need a calculator so we can do quick math today. You're going to get, it's really 4 formulas, but it's really only 2. You're going to get 2 formulas. Honest to God, you got to know how to use these formulas. They're easy formulas, though. Don't panic. Yeah. Go ahead. It's not a requirement that you have a calculator. It's just that I don't want to be spending 5 minutes doing one calculation. I'm going to say, hey, what's the answer? Type thing. We passed the point in math where we really kind of worry about, can you add, subtract, multiply, and divide easy numbers? Yeah. Okay, I think I got one. No plain Pac-Man on my calculator. Yes? Because I know you can. I have Mario, Pac-Man, and Donkey Kong on that. No plain.
You can get 5 inspiration.
You're mumbling. What?
You get 5 nights inspiration.
You can, exactly.
Really? Yeah, you can. What?
You can get.
Last year they were playing.
You can get. It's a calculator. Isn't that the coolest thing ever? That you can play Pac-Man on your calculator?
How do you put it on? You have to, like,
Oh, how do you put it on? I'll allow you to Google that yourself. You can figure it out. All right. If you were in 7th grade, maybe I'd help you, but you guys are 10th graders. You can tell me more things about electronics than I'll ever know.
Yeah, about a phone, not a calculator.
Well, then, if you know it about a phone, you can figure it out for your calculator.
There's not a exactly.
Yes, there are. You literally have a button that's called apps.
No?
You have not noticed that button on your calculator? It says apps?
Yeah, right here.
Oh, mind blown, right?
Oh!
It says apps. I've known some kids, so and we're not talking about maybe this year, but juniors and seniors, I've seen some kids, there's some pretty good apps for like studying for the AP history test and whatnot. So I've seen that as well too. What? Homework. All right. Do we have the sheets handed out already?
No.
Seth? I said grab the one that said geometry and hand it out.
Here I come.
Which one says geometry?
I'll let you figure that one out.
This.
Read it.
I can't read.
All right, here we go. So we got introduced to our first polygon last two. Well, it took us 2 days to get through the class. Triangles. We're going to see all the other polygons that exist in one class today. We're going to get, I said about 4 formulas. It's really just 2 formulas. Okay. Really important. All right, we did not write this down, so let's write this down real quick. As I looked at this class, I'm like, I'm going to change it for next year and have them write it down when we do the triangle one, but I'm not sure why I did it backwards. So we define a triangle as a polygon. A polygon is a closed. That means you can't go to the inside without crossing a line. Plane, that means it's flat. Figure consisting of segments joined at their end points. Segments joined at their end points. So by that definition, right, that is what a polygon. Polygon comes from the Greek poly meaning multiple, many, and gon means angle or corner, right? So that's where we get many angles. Those are what polygons are. Okay, there are a few rules about polygons. You don't need to write this down. You just need to listen. You ready? So if you are a polygon, the first rule is that your sides must be segments. Not sort of, kind of, sometimes, but always. Is that a polygon? Are the sides segments? Is that a polygon? We will have this shape later. It's called a sector. We will have this later in, I don't know, 10 or 11, chapter 10 or 11. But that's not a polygon. It has one side that's a segment, but the other one's a curve. Second rule is that the segments must be joined at their endpoints. So is that a polygon? Is that a polygon? Why not? Why isn't that a polygon? I did not join the two segments together, so not a polygon. And we get a third rule. This one's weird. It says this. All the intersections of the polygon must happen at the endpoints. You're like, well, what would it look like if they weren't? You see that shape? Is it made up of segments? Are the segments joined at their endpoints? Heck yeah. But I got an intersection, and that intersection didn't happen at the end of the segment. It happened in the middle or somewhere, not the end. So this is a shape, it's just not a polygon. Okay? And no, I don't know the name of it. All right, there is one complicated rule. It's the only rule I'm going to have you write down. All right, this one's complicated. I need you to draw the picture in box, what are we on? 2? No, 1B, I'm sorry. There's going to be two things you're going to draw. Draw this shape, don't make it too big. Now, I want you to put 2 points inside that shape. Put 2 points inside that shape.
Sorry, I didn't catch that.
I said 2 points inside the shape. Make sure that's in your locker by the end of class. How in the world did she think that I was saying Siri, or is that Siri or is that Amazon? All right. Put two points inside the shape. Now play connect the dots. So here's my 2 points. Play connect the dots. This is one type of polygon. Okay. Now draw that shape. Quickly though, quickly. The first one is going to be one type of polygon. The second one's going to be, check it out. This L is a polygon. It's made up of segments joined at their endpoints. All the intersections happen at the endpoints. It's a polygon. This time I want you to look where my finger is. I want you to put a point right there. And then draw another point somewhere on the long leg right here. Play connect the dots. What do you notice is different? If the segment that joins 2 points inside the polygon goes outside, it gets a special name. If the segment stays inside the shape, it gets another name. They're weird names. The top one, write this down, is called a convex polygon. A convex polygon is, well, it means that you can draw two points anywhere on the inside, and the segment that joins the 2 points will always be inside the polygon. In other words, it won't intersect the side. You may have heard of the word convex before. Anybody know the opposite of convex? Seth? Micah? Madison's got it. Concave. So the second one is going to be a concave polygon. You see the word cave in there. So there's like a, somewhere in the shape, there's a, yeah, it doesn't look like a cave, but there's a cave. If you can think of the letter C, right? If you made a C in the shape of a polygon, maybe you can see the cave. So here's the letter C. Well, there's the cave. That makes sense. And I thought about that this morning when I was going over the slides. Like, I should make that L a C, and then it makes more sense. But I didn't. But I will for next year. All right. Convex polygon, concave polygon, and we'll stop right there on silly definitions. We good? Now, it's not saying that all 2 points, the intersect, it will lie outside. It's saying that there can be 2 points. If I put my second point right here, then it would look like that one. But no 2 points on the convex polygon can ever be connected outside. We good now? Write faster.
I have a question.
Yeah.
What was our homework again? I missed that.
Remember, it's always on the board. Whichever one says no.
One that says geometry, boy.
All right. Now, box 2. Write this down, please. 2 columns. Number of sides and a name. And you have to, this is going to be critical for tonight's homework. Number of sides and name. I would almost say put this in your book of truth. I will let you decide once you see the list of whether it also needs to go in your book of truth. Okay? What's the first polygon we have? How many sides? So 3 sides, we call it a triangle. Do you have these memorized, yes or no? All the way up to 10? So maybe some of these might need to go into your book of truth.
Call it decagon.
Okay? You got to have them all in between, no? So the next one?
That is going to be a square.
No.
Or rectangle.
No.
4.
It's going to be 4, and its name is?
Rectangle.
No.
Square.
You already said it once. I was saying no to him.
Quadrilateral.
Quadrilateral. 4 quadrilateral sides, 4 sides. Yes, a rectangle is a quadrilateral. So is a parallelogram. So is a trapezoid. So is a rhombus. So is a kite. Right? They're all types of quadrilaterals. 5 is called a pentagon. As I said, you got to have these memorized or in your book of truth. Some of you probably do have these memorized. 6 would be, and by the way, penta means 5, hex means 6, tri means 3, quad means 4. 7, nobody remembers. There's 2 ways. Our book chooses the other word for 7. Right? The other word is hepta.
Oh,
Right.
it's septic.
Septagon is as well too, but
Will you accept septicon?
sure.
That's in green.
but not Decepticon.
Man, no Transformers in that.
Oh yes, we do. We literally have a chapter called Transformers.
Yes.
Oh my God.
Is it about convex?
No, it's about transformations,
Close enough.
but it's close enough to be transformed. 8 is an octagon. Octa meaning 8.
This is the one I don't know. Number
9 is, and I'll just say 9 is always on a test. Not my test, but whenever I see a test given for kids, they always ask about this one. I guess it's because nobody, I would say, think they would put the 7 in there, but they always put 9 in there. 9 is a, anybody? Nonagon.
A nonagon. Oh my goodness.
That's not a nonagon.
And then 10 is a decade.
I am anti-non-nonagon.
All right, which brings up the important question, what is 751 sides called? Any polygon bigger than 10, at least in this class, we will assign a variable that represents what it could be, and the variable we will choose won't be x, it'll be n. So guess what we call any polygon bigger than 10 sides? An n-gon. So n represents any number bigger than 10, right? And we call it an n-gon.
That's depressing.
And you will absolutely 100% see in our book will say, hey, you got an n-gon. What do you mean an n-gon? It means a polygon bigger than 10 sides.
It gets the antagon.
And oh, by the way, it would also apply to all the other ones. An n-gon could be a quadrilateral. An n-gon could be a triangle. Just n represents how many sides. All right. You get to decide what part of that needs to go in your book of truth, what part doesn't. If you could already have it memorized, you're good to go. If you don't, and we get to test day, and I say nonagon, you're like, well, I think that's 7 sides. You're going to miss it. All right, we've already talked about this. Karis, how do we name any polygon? We pick a letter, and then we go. We're also going to include the name of it. How many sides? Therefore, it's a, by box number 2, it's a So what's the name of this quadrilateral? A, B, C, D. But you could choose any letter as long as you stay on a black line. You go counterclockwise or clockwise. So I can also call this quadrilateral C, B, A, D. Seth, what can we not call this? Obviously, we can't call it triangle, but I'm saying we can't call it quadrilateral
CAED.
because you can't go diagonally. You got to go counterclockwise or clockwise. We got this?
You can't name him Bob.
In my world, you could. Okay. So up to now, we're just writing down definitions. Pretty simple. Now we got to turn our brain. Here comes the formulas. You ready? All right. All right. So think about this. If I were to start at a corner, and I'm not going to go to a consecutive side, that means a side next to it. I'm going to go to the side that's opposite it, right? We call that shape that I just made in red a name. Anybody want to take a guess? Yes, it's a segment. We call it a, it'll make sense when I give you the word. What direction is it going? We call it, therefore, we call it a diagonal. A diagonal connects two corners, right, two angles, of a polygon that are non-adjacent. We call it a diagonal. No, I'm not going to have you write down the definition. Okay? Oh, by the way, when you make a diagonal, guess what shape I just made? For this particular shape, I made two triangles. Hey, last two classes were on triangles. So it turns out you can turn any polygon into, and that is where we're going to spend the rest of the year on, is triangles. Because all polygons can be made into triangles. Okay? Typically, diagonals are indicated by a red dashed line. Not a rule, but typically. All right, so it turns out that all shapes that are polygons can be turned into triangles. How many triangles? Two. Okay, how many triangles? So let's start at a corner. It says you can't go to the one that's adjacent, you go to the one that are opposite. Well, this one is opposite, and this one is opposite. So how many triangles?
Right.
So in a pentagon, we can make at least, there's more. I mean, we can make diagonals from here as well, too. But the fewest number of triangles inside there is 3. How about a hexagon? Well, let's see. We start here, we go here, and then we go here, and then we go here. So it looks like we got, what, 4? You see them? Okay.
So many more.
Turns out there's a pattern here. How many sides? How many sides? How many triangles? Ooh, looks like it's being divided by 2. Let's see if that happens. 5 divided by 2 is 2.5. Well, that didn't happen. So 5 sides, 4 sides, 2 triangles. 5 sides, 6 sides. So what's the pattern? It's always going to be not one more. What? You're saying there's one more?
No, one more from the triangles. 2, 3, 4.
Looks to me like there's 2 less.
No, two triangles and
2 triangles, 3 triangles, 4 triangles.
Oh, right. I'm saying about the shape. It's the relationship between sides and triangles.
Oh, it's fine.
It's 2 less, right? Hey, what did Theorem 311 say? What did Theorem 311 say? Theorem 311 said sum of the interior angles of a triangle is 180. We can figure out the interior angles of any n-gon simply by figuring out how many triangles are in it. Well, I know how many triangles in it. It's going to be 2 less than the number of sides. That's going to be our first formula. So remember, Theorem 11 said that the sum of the interior angles of a triangle is 180. We just found out the pattern that the number of triangles inside a polygon is 2 less than the number of sides. We can get a formula out of this. It's our first one. So let's see. Calculators, ready? How many triangles? So how many degrees on the inside? 360. Where did I get that from? Well, each triangle has 180. There's 2 triangles. Hey, how many triangles? So how many degrees? How much?
740.
What? I heard 720 and I heard 540.
540.
740?
500.
540. Hey, how many degrees for a hexagon? 720. The formula is you take the number of sides, subtract 2, and then you multiply by 180. You need to write that down. That's 313. The first formula, you got to be careful. This is confusing. We're not talking about the outside. We're talking about the inside of a polygon. The inside of a polygon, if we count up all the angles and figure out how many degrees that is, it's always going to be n minus 2 times 180. N means the number of sides. 180 means 180. 2 means 2. All right, that was lame, but the confusion will be we will soon talk about exterior angles as well. We will soon talk about exterior angles. Chris, write this down. Book of Truth. This is the form we're going to use tonight. One of 4 that we'll use tonight. It's really only 2, but we'll talk about that here in a second. Some of the interior angles of any polygon, including a triangle. Hey, how many sides does a triangle have? 3 minus 2 is times 180, 180. Oh, I will enjoy when we don't have to wear a mask.
I can do my copy in peace.
I can talk in peace. All right. Hey, is this a hard formula? Is it a hard formula to use? Are you allowed to use a calculator in my class? So if I said it has 162 sides, could you figure out how many degrees? Really quickly. Because you got a calculator. Don't panic. All right. So how many sides? You with me? How many sides? How many degrees? Grab your calculator. Do the formula. How many sides? What am I supposed to do? Tell me what to do. Well, she's already told me the answers. I said, tell me what to do. 5 minus 2 is, times 180 is 540, right? This is not a very challenging thing to do. But you got to understand the formula, and there's going to be more formulas. Okay? So 313 is easy. All right. So the skill that you just learned was how to calculate the sum of the interior angles of any polygon. N minus 2 times 180. And the n minus 2 is in parentheses. All right. Well, how many degrees for a hexagon? How many sides? Minus 2 times 180. And that's as quickly as it's going to take you to do homework tonight. You're like, I'll never screw this up. Because you said I'll have a calc. It gets complicated. And if we stop right here, it wouldn't be complicated, but we're moving on. Next skill. All right. The exterior angles. Here's where it gets complicated. Okay. So how many degrees around the outside? What's your guess, by the way? You'd think like it'd be infinite, especially if we had an infinite number of sides, right? Remember yesterday in the last 2 classes, we made exterior angles. How did we make an exterior angle of a triangle? We had to make extra lines. So see the extra lines, right? So let me try to explain it to you. The first exterior angle is right here. So if I measure this, it would be there. If I measure this one, it would go here. If I measure this one, it would go here. And if I measure this one, it's go here. What do I just do with the stick? I made the stick go around 1 time. So intuitively, we would think that it would be 360 degrees. Well, that's not a proof. That's just me making a stick go around a circle. Well, let's see if the same thing would happen. So here's a pentagon. If I start right here and measure this angle, well, I'd measure it to there. This one I'd measure to there. This one I'd measure to there. And this one I'd measure to here. And it looks like I went out once again in a circle. It looks like if you do that for any polygon, that the answer, quicker please, is 360. That's not a proof. That's just me waving a stick around. We got to prove this. Okay? I'm going to show you a new type of proof. The new type of proof, you've done it before, is called an algebraic proof. An algebraic proof is we just do algebra. Right? So stay with me. Turn your brains on. Stay with me. If I just look at one of these angles, not all 5, one of them, what's the relationship between the interior and the exterior? It equals 180. So if I look at the sum of one of the interior angles plus the sum of one of the exterior angles, it must be 180. You with me? But I got more than one here. How many do I got? 5 of them, right? So if I talk about the sum of all the interior angles plus the sum of all the exterior angles at 180, it would be 180 times 1, 2, 3, 4, 5. In other words, the number of sides you have, right? Because it would be 180 plus this, plus this, plus this, plus this, right? That would be the sum of all of the interiors plus the exteriors added together. Stay with me. I know the formula for the sum of the interior angles. We just did it. What's the formula for the sum of the interior angles? That was the sum of the interior angles of any polygon. We think the answer to this is 360. We think if you add up all the exterior angles together, we get 3. I don't know if it's true, so I'm going to let it be x, and we'll just solve for x. Well, I know what all of those add together. It's 180 times the number of sides you have. I can solve this now. Distributive property real quick. What do you get? 180 minus 360. Hey, check it out. I got 180 in on the right side. I got 180 in on the left side. Guess what happens in algebra? Poof, they go away. Therefore, x is equal to, and you just proved now, not thought, not moved a stick around a circle. You just proved that the sum, remember x was this part, the sum of all the exterior angles is 360. Was there anything special about this shape? It could have been any polygon. So here's the first thing you got to wrap your head around. The sum of the interior angles always changes for no matter what shape you have. But the sum of the exterior angles is always, it's not a formula, it's just a fact. Okay, that's what you got to wrap your head around. If we're talking about the inside, it changes no matter what, depends upon what shape we get. Triangles are different than pentagons. Okay, but the exterior angles is always 360. So that's Theorem 314, and you just proved it algebraically. It doesn't matter what the shape is. The answer to what's the sum of all the exterior angles is 360. This is formula number 2. And you're like, well, that's not a formula, that's a fact. Great. So interior angles is n minus 2 times 180. Exterior angles, it's always 360. That's pretty simple. We're going to get 2 more. It gets complicated. Good? Okay. Hey, as soon as it says calculate the sum of exterior angles of a polygon, guess what the answer is? You're done. There's nothing to calculate. Right? What is the sum of the exterior angles of a, okay, you can stop right there and just write 360 and you're done. It doesn't matter what the shape is for exterior angles if you're talking about the sum. Okay? So 2 skills so far. The sum of the interior angles, n minus 2 times 180, and the sum of the exterior, it's just 360. Well, I said 4 formulas. There must be 2 more. You ready? We're recalculating all the angles or one of them? Were we calculating all the angles or one of them? Were we calculating all the angles or one of them? What? So the next 2 formulas tell us how much one interior or one exterior angle is. It's not complicated, but it is confusing when you put all 4 together and you don't read carefully. All right. Before we do that, we're going to write some different polygons. This doesn't need to be in your book of truth. I think you can remember this. The first one is called an equilateral polygon. An equilateral polygon is just a polygon where all the sides have the same measurements. Can look weird, right? Notice the red tick marks. It just means all the sides are the same. Doesn't say anything about the angles. That's called an equilateral polygon. I'm going to go a little bit quick here. An equiangular polygon, take a guess. Take a guess. What's the same? All the angles are the same. All the angles inside have the same measurement. Equilateral, equiangular. What would happen if we combine both of these? The sides are all the same. maybe 4 centimeters. And the angles are all the same, 120. What would look like? It would look perfect, right? We don't call it, I would love if this was called a perfect polygon. I think it should be called a perfect polygon, but we call it a regular polygon. A regular polygon is a polygon where the sides are the same and the angles are the same. Notice, it's not saying that the side measurement equals the angle. It just means that all the sides are congruent and all the angles are congruent. We call it regular. We will spend most of the time this year on regular polygons. Why? Because they're perfect. We like their shapes. Draw me a weird looking rectangle and we're not happy. Draw me a square. Draw me a square and you're happy because a square is a perfect quadrilateral. We good on these 3 concepts? Not too bad. Tonight for homework, they're going to say sometimes regular, sometimes they won't say regular. All right, so what about this is we get 2 more formulas. They're the challenging ones. Why? Because one, you got to read it. It's not going to say, oh, by the way, this is that other formula. You got to be able to read what it says. So we'll just talk about regular polygons now. Hey, what's the sum of the interior angles of a pentagon? Interior angles. Which formula do we use? N minus 2 times 180, right? Okay, how many sides, pentagon? 5 minus 2 is times 180. We've done that before, 540. Boom. Okay, so the interior angles is 540. Read, what's it say? What's the answer to that? Always. So exterior is 360. You're like, okay, why is he making a big deal? Because we get 2 more formulas here. They come. The next question is going to talk about interior angles, but it's not going to say what is the sum. It's going to say how much is 1. So we have to take this formula and do what? Because that'll give us all of them. Well, how many sides are there? So what we'd have to divide by? In a more general term, okay, now we're not dealing with pentagons, we're dealing with any polygon, you would have to divide by the amount of sides. What's the name of the amount of sides? N. So we take that formula there for this question right here. What's the value of N, meaning 1? Sometimes it will say 1. Most times it will say N. Notice it looks exactly like this, except it has the word and.
So the answer to that one.
Grab your calculator, divide that by 5. What do you get? It's our 5 sides, right? We get what? 108. What's the sum of, what is the value of an exterior angle? Same process. All of them added together equals what? How many sides do we have? So I'm going to take 360 and divide by, in a more general term, we're going to take the formula 360 and divided by n. So calculators, what's the answer? How much? You're done. Okay, so you're like, some of you are like, well, that's not too complicated. This is complicated because it's 4 different wordings, 4 different problems, 4 different formulas. And it can become a little confusing. Yeah. I'm going to show you that here in a second. All right, so let's do one of these together. Here we go. Hey, what's the shape? How many sides does a hexagon have? Grab your calculators. Let's do this. So what's the sum of the interior angles? That means all of them. Formula, what's the formula? What's the formula? N minus 2 times 180, or 6 minus 2, 180 in this particular case. We plug that into a calculator. What's the calculator say? Done. What's the sum of the exterior angles? Always. It's always 360. Homework is going to ask you one of these 4. That's kind of why it's complicated. Right? Hey, what's an interior angle? Well, we take the interior angles and we divide it by, in this particular case, by 6. There's 6 sides. The formula, though, is n minus 2 times 180 divided by n. We'll write it down here in a second. So we get 120. How about the exterior angle? What is one exterior angle? Okay, 360 divided by 6 is 60. So you tell me, is it complicated? No, especially I'm allowing you to use calculator. What's complicated is questions for homework will say one of these, and especially if it gives you this one, guess what you got to do? I'm sorry, this one. You still got to do the first one in order to get to the last one, because you got to know how many degrees there are in total before you divide by, in this case, 6. So if I ask you this question or even this question, I'm really asking you the other one as well. All right, we better write this down, box 5. Maybe it might want to go in your book of truth. And then we got 2 minutes, we're good. Maybe you want to write this in your book of truth instead. Hey, what's the sum of all the interior angles? What's the formula? Okay. What's the sum of all the exterior angles? What's not formula? I'm not telling you the shape. Give me one interior angle. What do we do? This should say of a regular polygon. N minus 2 times 180 divided by n. And the last one, 360 divided by n. This should say polygon, polygon. Micah had a good question. You're going to see a table, and it will be confusing. So all you do is, if they give you one interior, then this would be equal to that number, solve for n. That's how you find how many sides. If they give you one exterior angle, use that formula, set it equal to the number. So we'll say like it's equal to 67 degrees. Solve that formula, and that's how you find out how many sides. I would suspect that some of you will struggle with the table, at least a third of it. Okay? I kind of just told you how to do it, but you might not remember. Good luck on your homework. Have a great weekend. Do something fun. See you guys on Monday. All right, e-learners, if you have any questions, send me an email. If not, I'll see you guys next week as well. Ciao.